Welcome to Recording 1B in our series on completing the square for Unit 3, Chapter 3 of quadratic functions. We look here at how we can convert quadratic functions from standard to vertex form by a process called completing the square. That is, using the skills learned in Recording 1A for creating perfect square trinomials. Let's have a close look at the vertex form of a quadratic function. That form is y equals a outside of x minus p squared plus q. That x minus p squared portion, that represents the factors of a perfect square trinomial. So for example, if I give you this function, y equals -2 outside of x minus 5 squared plus 3, the x minus 5 squared, that can be expanded to form the perfect square trinomial x squared minus 10x plus 25. You may recall from our last clip, we have found a way to shortcut the FOIL process for squaring a binomial. It is x squared plus twice the d value times x plus the d value squared. So in this case, x minus 5 squared, the perfect square trinomial, would be x squared plus 2 times -5x, because our d value is -5, and plus the -5 squared, because again the d value is -5. So it gives us x squared minus 10x plus 25 for the perfect square trinomial. Now, how can we use that to create a quadratic function in vertex form if we're given the standard form? Well, there are two basic types of cases to consider. Case 1, if you've got just y equals x squared plus bx plus c, the a value is 1. Okay, so it's really a 1x squared right there. So we're, in this first example, we have 1x squared minus 10x plus 25. The first step here is to group the first two terms, the x squared and the minus 10x in this case. So we just put them in parentheses or brackets, as we say in Newfoundland, like so. Then it says create a perfect square trinomial in the parentheses. So we've got x squared minus 10x. Now remember that -10 is twice the d value. So our d value is -5. So now we've got to square the d value to get the number that needs to be added at the end to create that perfect square trinomial. Now, that plus 15 is outside the brackets, but there's a catch. I cannot add something new to an equation, or else I'm going to cause it to be an imbalance. I have to subtract off the same amount. So in this case, I have added 25, so now I subtract off 25. Now, because there's nothing multiplied in front of these brackets, I can arbitrarily, or choose to, move the bracket over to here. Therefore, the last step is to factor the perfect square trinomial. Remember, the factors are of the form x plus d squared. So our d value in this case is -5. So it's x minus 5 squared. And we just add the -25 and 15 that are outside to get -10. So now we have the vertex form where we could easily read the vertex of the parabola should we so desire. Case 2 is when the a value is not equal to 1. So for example, convert y equals 5x squared minus 10x plus 15 to vertex form. First step, now is group the ax squared and bx terms using the parentheses. So I do that. But now there's a catch. I have a 5 in front of that x squared, so we don't know how to create perfect square trinomials doing that, at least not in this course. So we're going to remove the a from the parentheses like it was a common factor. So I take the a out of the two terms, x squared minus 2x. Notice I do not take it out of the 15. That's not in the parentheses. So I need to create a perfect square trinomial inside the parentheses. So remember, the negative 2 is twice my d value. So 2d is equal to negative 2d is negative 2, and I get d, therefore, is equal to negative 1. Squaring that gives me 1 to put in this blank. But whatever I've added in, I have to subtract off. Now, the only issue I have is I don't have the x squared minus 2x plus 1 isolated here to make a perfect square trinomial. I get this minus 1 in the way. The kicker is I cannot put it outside the brackets until it's first multiplied by the 5 that's in front. So I'm really subtracting 5 times negative. So I'm really bringing 5 times negative 1 outside the brackets. Now the process is simply to factor the perfect square trinomial that I've created in here. And remember, the factors are of the form x plus d squared. Our d value is negative 1. And then we simplify outside. 5 times negative 1 is negative 5 plus 15 is 10. In conclusion, a quadratic function can be changed from standard form to vertex form by creating perfect square trinomials, that is, by completing the square. And if the value of a in the standard form is not equal to 1, you've got an extra step.